recording. And here we are. And last time we discussed about latent class analysis example. If you remember discussion, so last time we tried to divide Czech kids in their first grade of elementary school according to their attitudes to mathematics. The survey which was present in our data file was TIMSS 2011, which is very famous and one of the best international surveys, which is measuring especially skills in mathematics and science. Science means in Czech subjects, so it is some combination of, I would say, physics and chemistry mostly. And we were mainly interested in 6 questions that were measuring attitudes toward mathematics in the first grade. And we tried to find some types of kids according to these attitudes. So if I will switch into Jamovi and I will try to find latent class analysis from the last lecture. So it was based on mathematics full class LCA data. So here we are. So we can check very briefly previous results. So if you remember, we discussed about 3 possible solutions. The first solution was based on 2 classes, and there was one quite big class, approximately 3/4 of kids created this class, and one small. And according to this table with estimated class conditional probabilities, or according to this LCA plot, which is present here in Jamovi. Once again, original source is package POLCA from R. So you can find very quickly that bigger group of kids are those who have quite positive attitudes towards maths. Once again, here the size of these lines is relative, and the higher the size is, the bigger is disagreement. So if we have here very small pieces for enjoy, interest, like, an important statement, so it means that these kids mostly agree with these statements and they disagree. They wouldn't like to have mathematics, and mathematics is boring. So these are kids that are, I would say, in favor of mathematics, at least in the first grade. Of course, it would be interesting to find similar results, for example, from PISA survey, which is administered in 9th grade. And also you can expect that these results would be much worse in comparison with first graders. And the second group, just opposite structure, I would say, of these conditional probabilities. So these are kids that are, even in the first grades, against mathematics. So this was 2-group solution. I will go briefly also through recap through 3-group solution, which is just the next one. So the biggest group is approximately 70% of kids, the second approximately 1/5, and the last one, the smallest one, approximately 1/10. And if we go into results, so we can very simply recognize that group number 1 currently is the group of those who are for mathematics once again. Then we have just opposite pattern. So these are these kids. And there is also some special group somewhere between. So I would call these as neutral, this one as positive, and this one as negative towards mathematics in the first grade. And I will only very briefly recap that we also try to analyze 4-group solution, and it was, at least from interpretative perspective, maybe slightly complicated, and that's why we decided that's a pragmatic solution currently, that maybe 3 groups will be the best for further analysis. Once again, there are 2 possibilities how we can decide about number of latent classes, I mean in exploratory regime, which is present here in GeoMovie. And the first one is, I would say, substantive. So I try to find solution which is, according to my opinion and according to further interpretations, quite easy and easy to understand. And also, I try to avoid to find classes that would be very small. Very small means that the class would consist of something like 50 people, 5% of all kids, etc., etc. So that's, I would say, pragmatic or substantive decision about number of classes. There is also alternative, I would say, statistical criteria could be applied for decision about number of latent classes. And here in our results, mainly according to classical recommendations, you should apply Bayesian-Schwarz information criteria, so-called BIC. And this criteria is designed as the smaller, the better. So I would go through all possible solutions and I will try to find a solution with the lowest BIC value. So that's one option that could be applied. My personal experience with latent class analysis is saying that if you follow this criteria, so it means you try to follow the smallest value of BIC, usually you find very complicated models with too many latent classes. Usually also some of these latent classes are quite small by absolute value or by relative value. And also interpretation can be sometimes very, very difficult to provide. So that's why as a qualified statistician, I would recommend you to follow non-statistical recommendations for decision about number of latent classes. Maybe it's strange, but it works, I must say. Also, there is another option that can be applied, but unfortunately not in these GeoMovie outputs. Here we have also 2 tests. The first one is based on chi-square. It is directly called chi-square. Second one is based on likelihood ratio, and mainly this likelihood ratio test statistic could be applied for comparison of individual models. There is a possibility to compare differences in these likelihood ratio statistics, but unfortunately, and don't ask me why, in GeoMovie, you cannot find degrees of freedom that are related to this test and that are also applied to this differential testing. So that's why it's nearly impossible to apply this test currently in implementation of latent classes in GeoMovie. For example, if you would switch into SPSS, in which the same package, so it means PLCA from R is implemented, you can also find degrees of freedom. Don't ask me why it is not present here. So that's about number of classes and implementations. And as I decided, according to pragmatic decision, so quite nice interpretation and also differentiation, at least 3 classes. So I would like to work with this solution. So it means ideally, I would like to save in my data this 1, 2, 3 coded variable with latent classes, and maybe I would like to try to find whether it works. For example, I would expect that if there would be groups that have attitudes which is positive towards math, maybe that the result in mathematics measured by some test of mathematical skills will be much better than for those who are negative or even neutral to mathematics. So that's my expectation. Also, you can maybe expect, according to some, I would say, prejudice in the society, that there will be maybe more boys than girls in the first group that have a positive attitude toward mathematics, etc., etc. So for all these further analysis, it would be nice if I could find in the last column in my data matrix something what I would call membership into different latent classes. Fortunately, Gemovi can provide this computation directly for us. So it means it will assign new one variable if we ask for this into data matrix, and we can use this new variable for further analysis. Only what is maybe slightly user non-friendly is the property that new one variable will be coded as 1, 2, 3, and we need to assign some meaning that the first group will be those who are positive, second that are neutral, and the third one which is negative. And maybe before we start to provide this new one variable into data set, I would like to add also one more comment. In this settings, so it means in this computation of 3 classes, this latent class variable is not only nominal by its property, but, and that's a random effect, it is, according to my opinion, ordinal, as this is, I would say, the most positive attitude, somewhere between, and the most negative attitude. But once again, that's random. Sometimes it can happen that the first class would be positive, second one negative, and the third one neutral. So if you would like to change it into ordinal variable for some analytical purposes, then you should recode data. So that's only one comment to the property of this new latent class variable. By default, so it means this is the logic behind latent class analysis. This variable, so it means latent class membership, is treated as nominal. Only sometimes you can assign property that is saying, no, it is also ordinal variable. So that's it. So if I double click into our previous analysis, so I can go directly into save option. And here we have the main option, which is save class membership. So if I check this dialog box and once again open my data file, so I hope it would work. And I should find, ideally, still not on my data, but I hope that it works at least on your data set. Yeah, currently I can see it. Membership 1, 2, 3, 4 should be present here. And once again, maybe for easier understanding, it would be nice if you add some labels that 1 is positive, 2 is neutral, and the third option means negative. One small comment once again, but I remember that we discussed about this property of Gemovi. If some variable is computed directly in Gemovi or saved in Gemovi, usually you can see some symbols. So here you can see some small gray point, which is saying this is variable which was saved directly in Gemovi. So you can find this is not original variable, but it is somehow computed variable directly in Gemovi environment. So if I double click into this membership variable, so I can assign labels. So I can go into levels here. And I hope I can click here, but not on my computer currently. I'm not sure why is this so. Is it working on your computers? Sorry for that. Currently, it's not assigning. Oh, don't know what's the problem with level assignments currently on my computer. So maybe I will skip it, or is it working on your computers? No? So sorry for that. I'm not sure if maybe for computed variable, it's not possible to assign. I'm surprised. Maybe I will only try to change into variable settings, but it is still the same. So sorry for that. I will try to fix this problem and let you know next time. So sorry for that. I would go once again back into data matrix. At least we know what is 1, 2, 3 currently. So we can go across this problem. And for simple computation, I would propose, first of all, I would like to compute the average results of mathematical scales. There is a variable which is measuring mathematical skills of kids. This is variable which is called ASMMAT. This is some international measurement scales for mathematical skills in the first grade. The basic property of this variable is that the international average is 500. Standard deviation internationally is designed as 100, so it is somehow standardized variable. So it means the higher the score, the better skills in mathematics for first graders. And we would once again expect that for the first group, this level of mathematical skills will be the biggest. And maybe for the last one, for those who have negative attitudes towards maths, it will be the lowest. So currently, I would like to compare means for this ASMMAT variable for these groups created by Latent classes. So I guess that the easiest would be to use exploration. And here descriptives. And here I would take the variable measuring mathematical skills. So first one cardinal variable in my data set. Once again, ASMMAT01 it is called. And I would split my results by membership, which is the last one variable. So, and if I split these results, I can find at least means. So I can see that for the first group, the mean is 506. For the second one, 522. And for the third one, 495. So I would expect maybe bigger differences at the beginning. Quite surprising is that for the second group, once again, they are somewhere between positive and negative attitude. Results are even slightly better than for those who are saying that mathematics is fun, I like mathematics, etc., etc. So it could be slightly surprising, but still there is at least some difference between those who are positive or neutral and those who are negative. But once again, I would expect maybe bigger results. So that's only for us to know that results are maybe not so impressive as we expected. And if you have here another variable, so you can also combine these results. So I maybe, for example, as one result, would take IT sex, so it means a variable differentiating boys and girls, and try to find whether proportions in these three latent classes for boys and girls are similar or not. So if I would like to provide contingency table or cross tabulations in Chemovi, I would go into frequencies. So frequencies means procedures mainly designed for categorical data. And if I would like to find a classical contingency table, I would go into the second section, which is simply called as contingency tables. And here the basic procedure for relationship for two variables is called independent samples, chi-square test of association. So if I click here, so I can ask for rows and columns. It depends on your decision. So I would decide that IT sex would create rows. And last one variable in my data set, so it means membership to latent class is creating columns. So here we are. And my proposal is that maybe we should change statistics from classical observed counts or absolute figures to some relative figures. So I would go into statistics, cells, and here I would check row percentages, and I would cancel observed counts for simple insight. And here maybe we can recognize what was the problem in previous analysis. Sorry that I didn't announce I knew about this problem in Chemovy. And the problem is that 3 latent classes that were present in my chart previously, so here it is, are not the same as ordering of individual codes in final data. As we know that the biggest latent class was the first one, but in Chemovy, as you can find, at least according to this contingency table, the biggest is second group. So here we have those with positive attitudes. Here we have those with negative attitudes, first one, and the third one are those who are neutral. Don't ask me why there is some small mistake in implementation in Chemovy. I can compare it with implementation of the same package in SPSS, and in SPSS it works properly. But still, we can go maybe back for a moment to the previous discussion about the averages of mathematical scales, and now maybe results are even more understandable, as the second group is positive attitude to maths, and they have the biggest and the best result from mathematical test. The second best, group 1 and group 3, the poor, but still there is quite big currently difference between those who are positive and negative. So it is much better than previously discussed, according to my opinion. And now, once again, we are trying to analyze whether structure of girls and boys, according to their attitudes to maths, is different in the 4th grade. And you can see, I would say, very minor differences as for those who have negative attitudes, 1/4 of girls, but for boys, it is approximately only 1/5, approximately 20 in percentages. For those with positive attitudes, 68 versus 71, so slightly bigger proportion of boys, and then small difference, 7 versus 8.5 for the last one, which is neutral category. So here I would say there is some small difference in these structures, but take into account that this sample size is quite big one originally for Tim's survey. We administered tests and questionnaires for approximately 4,500 kids. So this is quite big evidence that there would be some minor difference in structure of attitudes to mathematics between boys and girls. So it would be my conclusion. And that's why if you go down to the next one table, which is measuring the relationship between gender or sex and attitudes to mathematics, you can find that this result is measured by chi-square test as statistically significant. So chi-square test criteria is quite big one based on 2 degrees of freedom, as we have 2 rows and 3 columns, so 2 minus 1 multiplied by 3 minus 1, and p-value is very, very low. So it means that not only in my data, but also in the whole population, so it means it is approximately 100,000 of kids in the Czech Republic in the 4th grade, there would be some, and we know, minor difference between proportions of individual attitudes to mathematics for boys and girls. And last one comment that I would like to add to this, I would say, latent class advanced analysis is that, of course, you can take this final result, so it means this membership, as dependent variable, and you can, for example, use it for models such as logistic regression. So you can try to find what is influencing from other phenomena, not only from those original attitudes measured by 6 items, what is influencing positive and negative attitude to mathematics. For example, you can try to find whether, for example, education of their parents, support of their parents, number of hours they have of mathematics, etc., can be somehow influencing. So you can try to interpret what is behind the scene by this model, this membership from latent class analysis as dependent variable. And also in another analysis, you can apply this membership into 3 latent classes as independent variables. So for example, you can try to find whether these attitudes and other phenomena such as school which is visited, etc., is influencing result in mathematical tests, etc., etc. So you can use this variable, and once again, by default, this is variable which is nominal. And if you would like to change it, and currently it is possible in this case, so you can change codes by recoding, and you can create ordinal variable. So that's all about analytical options in latent class analysis. And I would like only to mention that we have at least two very close techniques to latent class analysis. One, which is called log linear analysis, and the small difference, I would say, between log linear analysis and latent class analysis is that for log linear analysis, I try to find model of relationship of more than two nominal or ordinal variables, but I am not finding any latent variable behind the scene. I'm only trying to prepare the model of relationship between variables. In latent class analysis, I'm also trying to find the model for relationship, but I'm trying to interpret this relationship by some hidden latent dimension, which is called latent class. So this is a small difference between log linear analysis and latent class analysis. And there is also special sub-model of log linear analysis, which is called logit analysis. And for logit analysis, this is nearly the same as for logistic regression. So I have set of nominal or ordinal variables, but only one is treated as dependent and the rest are treated as independent. But the small difference between logit and logistic regression is that for logit analysis, no independent variable is cardinal. All of these variables are ordinal or nominal. So these are very close techniques to all the rest previously discussed, so in latent class analysis and also logistic regression. So that's all for latent class analysis.